Okay, ladies and gentlemen, here we are. We're looking at the Math 1033, Section 2.1 lesson plans. The first part of these lesson plans involve evaluating functions. So f of x is equal to the opposite of 2x plus 3 is the first function. G of x equals 5x squared minus x is the next function. H of x is equal to the absolute value of x minus 7, and m of x is equal to 3. Now what you're asked to do here is to find the output for each of the following. So let me take us back. Hang on here, this cursor's a little temperamental. Okay, what you're asked to do is you're asked to find f of negative 3, then you're asked to find g of negative 3, then you're asked to find h of negative 3, and then you're asked to find m of negative 3. So in this particular problem, negative 3 seems to be a popular input, but notice you're putting it into three different functions. When you see this notation right here, f of negative 3 is the way you read it, and what you're being asked to do is to put the number negative 3 into the function f. So what it tells me to do is to look up at the function f, and you see where the cursor is flashing. F of x is defined as the opposite of 2x plus 3. That x just stands for input. Well, what we're feeding this function is the number negative 3. So to evaluate it, negative 2 times negative 3 plus 3 is equal to 6 plus 3, which gives me the answer 9. Therefore, f of negative 3 is equal to 9. And what that means is when I put negative 3 into the function as a domain value, that's called input, I get the answer 9 out as a range value, which is the output. So, now we're asked to find g of negative 3. Well, come up here with me. Here we go. Let me get my cursor. Here we are. G of x is 5x squared minus x. So because there are two x's for the rule of this function, that means that every place you see an x, we put in a negative 3. So look what I have down here. 5 times the quantity negative 3 squared, and then minus a negative 3. A very good way to evaluate a function is every time you're replacing the value of the variable for a specific quantity, put it in little parens. So notice how we get 45, right? Negative 3 quantity squared is 9. 9 times 5 is 45. The opposite of a negative 3, or subtracting negative 3, is plus 3. Thus our answer is 48. Negative 3 goes in, 48 comes out. H of negative 3. Well, look up with me. H of x is the absolute value of x minus 7. So I have my absolute value bars, but I put a negative 3 in the place of x. Now let's work inside the bars first. Negative 3 minus 7 is negative 10. However, when I take the absolute value of negative 10, it becomes positive 10, and that's my answer. Now, the last function asks me to find the value for m of negative 3. Now notice what's weird about this little function here. M of x is equal to 3. Notice that there's nothing on the right-hand side of this function, the right-hand side of this equation, which represents a function. There's no x value. So that really confuses students sometimes, but what this is actually telling you is when you just see a number as an answer for a function, that means that what you have is a constant function. So in this particular case, if m of x equals 3, what that's really telling you in math talk is no matter what you put into this function, you're always going to get out the answer 3. That's why it's referred to as constant. Therefore, m of negative 3 is equal to 3. In fact, that -3 that we were putting in had no bearing on anything. Because this was a constant function, we knew the answer was going to be 3. So if I said, what's m of 100? It would be 3. What's m of -4,000? It would be 3. That's how you determine and work with a constant function. All right? Let's look at the next part of this. Okay. Suppose you're asked to write a formula for the function c, which computes the circumference of a circle, and the circle has a radius of length r. Now, from past lessons, you know the formula for circumference. C is equal to 2 pi r. But the directions here said write a formula which represents a function. So instead of just saying C equals 2 pi r, notice what I wrote. C of r is equal to 2 pi r. And what that basically indicates to me, and this actually should be a capital R because these are both the same r. So C of capital R is equal to 2 pi r is my formula. First question. Find C of 10 and give an exact answer. Well, when I plug 10 in for r, 2 pi times 10 becomes 20 pi. And since we're measuring circumference, that's just, in this case, measured in feet. So the answer would be 20 pi feet. Now, notice when it said give an exact answer, it means exact. It does not want you to punch into your calculator. Pi is approximately equal to 3.14. It's not exactly 3.14. Therefore, when I ask for an exact answer, it's appropriate to leave pi in that answer. Now, the next directions ask you to find C of 10 and round the answer to the nearest tenth and interpret the resultant words. Well, 20 pi is the answer from above. This squiggle doesn't say equals, it says approximately equals. If you use the pi key on your calculator, which all calculators have, you should always use the pi key. 3.14 was something that you've been taught in previous courses, but actually pi is a non-terminating, non-repeating decimal. When you're evaluating it, it's safest to use the pi button on your calculator. So what I did is I took 20 times pi using a scientific calculator, and I got the answer 62.8 feet approximately. So what this means is if a circle has radius 10 feet, then the circumference of that circle, if you walked around the circle, you'd be walking approximately 62.8 feet. And we'll stop this lesson right here, and I will continue with another Camtasia production.